If you haven't done so yet, please pause the video and attempt to solve the question on your own before listening on. Our first step is to take a look at an equation that relates the relative accelerations depicted in this situation. We're going to go ahead and let A sub CE equal the acceleration of the coin relative to the elevator. A sub EG will be the acceleration of the elevator relative to the ground, and then A sub CG will be the acceleration of the coin relative to the ground. Probably a good idea to pause the video and read those over a few times just to make sure you understand what each acceleration denotes. And it turns out that these accelerations are related according to the following equation. In essence, the sum of the first two accelerations will equal the third acceleration. Now, two of these values are actually known. The question states that when the occupant drops the coin, its acceleration relative to the cab is 8 meters per second squared downward. So that value would correspond to A sub CE. So in essence, this is going to turn out to be negative. Notice it's negative because the acceleration is downward. Also, the acceleration of the coin relative to the ground would be negative 9.8 because relative to the ground, the coin is in free fall. It's just falling towards the ground, so the A sub CG would be negative 9.8. We'll go ahead and plug in the values and solve for A sub EG. And when we add 8 over to the right-hand side, we can see that A sub EG will equal negative 1.8 meters per second squared. So this is a value that we're going to hold on to and use momentarily. We will next draw a free body diagram of the elevator with its occupant. And the two forces acting on the elevator and its occupant are the downward gravitational force, mg, and the upward tension force present in the cable. According to Newton's second law, we know the sum of these two forces will equal the mass times the acceleration. Notice that the acceleration in the problem is going to be the acceleration of the elevator relative to the ground, and that is indeed the value that we had found earlier. For the sum of the forces, we have the positive tension force and the negative gravitational force. Since the question is asking for the tension, we can solve the equation for tension by adding mg to the right side. And then we could factor out a term of m. We have the value of mass given to us in the question as 2,000 kilograms. Again, A sub Eg we found earlier, and then of course g is 9.8, so we can plug in all the known values. And when we compute this expression on the right-hand side, we see that the tension is equal to 16,000 newtons. You could divide by 1,000 to convert that into kilonewtons, so that would be 16.0 kilonewtons, and that is indeed the correct answer. Thanks for taking the time to watch the video. If you liked it, please subscribe to the channel and click the thumbs up icon. Also, you are welcome to send in your own question to the email address on the screen, and I'll do my best to post a solution to your question on YouTube.